Okay, I see we are live. Let me check Restream chat application. Okay, I'll deal with it later. Sorry about this. So, on the previous stream, we started chapter 9 error handling, and basically we passed to section 9.1 and 9.2. So, in 9.1 it was unrecoverable errors with panic. There we can use macro panic and it just finish your app in case of error. And there is another option where we can return result instead of just close the app, and there is we can have some code branches where we can handle okay situation and error situation. Yeah, practice a bit with how we handle this situation with the match, etc. What else interesting? Yeah, the shorthand for propagating errors, question mark operator is I think quite nice. You see the initial code like this here, and ends up with something like this, just 3 lines or even less, but yeah. And now we're going to read section 9.3 is to panic or not to panic. But yeah, first I think I forget to update the title, so let me quickly do this. Oh, it's still, yeah, it's still good. We find with the title of the stream. So yeah, this in this section it describes what situation we might prefer to panic, or in some situation we prefer to have result. So here is a discussion where we want to do each case. So how do you decide when you should call panic and when you should return result? When code panics, there is no way to recover. You could call panic for any error situation, whether there is a possible way to recover or not. But then you making the decision that the situation is unrecoverable on behalf of the calling code. When you choose to return result value, you give the calling code options. The calling code could choose to attempt to recover in a way that appropriate for this situation, or it could decide that an error value in this case is unrecoverable. So it can call panic and turn your recoverable error into unrecoverable one. Therefore, returning result is a good default choice when you define a function that might fail. So yeah, basically, for example, you have a function which have potential situation where code can fail, and you need to decide. If you decide to panic, the outside of this function, everyone who will use this function, they will not be able recover from this situation because they don't have a choice. The program will stop, and I feel like it's not the best choice in many situations. On the other hand, you can use result, and the result give you option how you want to deal. If the person who will use your function want to panic, he can do it on his side. If not, he will able to do it in proper way and handle the error situation and OK situation. So in situations such as examples, prototype code and test, it's more appropriate to write code that panics instead of returning result. So yeah, code prototype when we are moving fast, and tests we don't really worry about. It's not like client application which will be really disappointed if it's suddenly stopped. So yeah, examples, prototypes and tests is a good place for panic. Let's explore why, then discuss situation in which the compiler can tell that failure is impossible, but you as human can. The chapter will conclude with some general guidelines on how to decide whether to panic in library code. So yeah, library code is just different from some your binary code, because library is something that will have external users and it will affect them, and that might be need some different behavior than you think is good in the first place. So let's take a look. So examples, prototype code and tests. When you are writing an example to illustrate some concept, also including robust error handling code can make the example less clear. In these examples, it's understood that a call to a method like unwrap that could panic is meant as a placeholder for the way you want the application to handle errors, which can differ based on what the rest of your code is doing. Yeah, so error handling can add some complexity in the code, and when you try to explain something, it can affect simplicity. So basically it's maybe you won't just use something like unwrap. Similarly, the unwrap and expect methods are very handy when prototyping before you're ready to decide how to handle errors. They leave clear marks in your code for when you are ready to make your program more robust. So yeah, when you're prototyping, like basically when you're developing something new, you don't know yet how to write to properly this feature, and you just need find solution first. So you want to move faster, and obviously just have expect, unwrap or panic. It's fast way to code. So yeah, you're basically using this, but after you find the solution you like, usually it makes sense to do some refactoring or even rewrite it from scratch, because it's very different when you just looking for solution, you trying thing, you prototyping, and then when you already know what you're gonna do, you can write more clean, nice code, more robust, etc., error prone, and things like this. If a method call failed in test, you'd want the whole test to fail, even if that method isn't the functionality under the test, because panic is how a test is marked as failure. Calling unwrap or expect is exactly what should happen. Yeah, in test, definitely. If you we haven't read about test yet. It's actually chapter 11, I see. But generally, if something goes wrong in test, you just want to fail all the tests, and it's just a sign someone should go and take a look what wrong with the test. Something is not expected. Maybe there is problem in the code, maybe it's problem in the test, but anyway, yeah, you should go and take a look. So we don't need any result logic there. So cases in which you have more information than compiler. It would also be appropriate to call unwrap or expect when you have some other logic that ensure the result will have an OK value. Okay, but the logic isn't something that compiler understands. You'll still have result value that you need to handle. Whatever operation you're calling still has the possibility of failing in general. Even so, it's logically impossible in your particular situation if you can ensure by manually inspecting the code that you'll never have an error variant. It's perfectly acceptable to call unwrap. And even better, to document the reason you think you'll never have an error variant in the expect text. Here is an example. So yeah, we in this example you see we hard-coded the value of IP address. We don't receive it from the third-party source from API or whatever, from the user input, etc. So we always knew it's fine. So we can just say we hard-coded correct value, so we will never fail in this situation where it's wrong. But you still it's not on the time of execution, but in development you can delete something by mistake or etc. And you will saw the panic which direct you the exact place. So yeah, nice example. Exactly. We are creating an IP address instance by parsing a hard-coded string. We can see that 127.0.0.1 is a valid IP address, so it's acceptable to use expect here. However, having a hard-coded valid string doesn't change the return type of the parse method. We still get a result value, and the compiler will still make us handle the result as if the error variant is possible, because the compiler isn't smart enough to see that this string is always a valid IP address. If the IP address string came from the user rather than being hard-coded into the program and therefore did have a possibility of failure, we definitely want to handle the result in more robust way instead. Mentioning the assumption that this IP address is hard-coded will prompt us to change expect to better error handling code if in the future we need to get IP address from some other source instead. Yeah, good point. So if we, the minute we write this code, everything fine, but in future, yeah, for example, you did it for test, you write this code, you confirm it's working, but in future this function will use to get some input as IP address. So what you're gonna do, change this part to accept something else here, but you might not change this part because you're looking, oh, okay, this code was working, I don't care about what else going on there, I just replace it here. Maybe not in this obvious situation, but in this it can be happen as well. So yeah, and then if you did wrong input, you will see this error and you can understand something wrong here. But even if you didn't catch it in runtime, you just reading the code, okay, hard-coded, I changed it, so it's not hard-coded anymore. We need to do something about it. So yeah, writing the good text here in expect is looking important if you're not going to handle error cases. So guidelines for error handling. It's advisable to have your code panic when it's possible that your code could end up in bad state. In this context, a bad state is when some assumption, guarantee, contract, or invariant has been broken, such as when invalid value, contradictory values, or missing values are passed to your code, plus one or more of the following. The bad state is something that is unexpected, as opposed to something that will likely happen occasionally, like a user entering data in the wrong format. Your code after this point needs to rely on not being in this bad state rather than checking for the problem at every step. There is not a good way to encode this information in the types you use. We'll work through an example of what we mean in the encoding state and behavior as types section chapter of 17. Yeah, close to the end of the book. If someone calls your code and passes in a value that don't make sense, it's best to return an error if you can, so the user of a library can decide what they want to do in that case. Yeah, exactly. If like it's some external user, we want to let them decide what they want to do. However, in cases where counting could be insecure or harmful, the best choice might be to call Panic and alert the parent person using your library to the bug in their code so they can fix it during development. Similarly, Panic is often appropriate if you're calling external code that is out of your control and returns an invalid state that you have no way of fixing. Okay. So it says there is still might be the situation you want just, yeah, if it kind of mistake possible only on the development level, you probably prefer to panic so developer can fix it before release. However, oh, have new follower. Nice to meet you. Thank you for the follow. However, when failing is expected, it's more appropriate to return a result than make a panic call. Examples include a parser being given malformed data or an HTTP request returning a status that indicate you have a hit rate limit. In these cases, returning result indicate that failure is an expected possibility that calling code must decide how to handle. So yeah, basically all HTTP request is like it's very expected that it will fail because it's network. It always at some point it will fail, and of course we don't want to just panic on it. We want to handle the situation like there is network, say to user something like there is network connection error, try again, and or maybe we want to try several times ourselves before the let user know it's something wrong because it may be a small glitch of network, etc. So definitely network request is something we want to use result here, not panic. When your code performs an operation that could put a user at risk if it's called using invalid values, your code should verify the values are valid first and panic if the values aren't valid. This is mostly for the safety reason. Attempting to operate on invalid data can expose your code to vulnerabilities. This is the main reason the standard library will call panic if you attempt to an out-of-bound memory access. Trying to access memory that doesn't belong to the current data structure is a common security problem. Yeah, it's obviously a good reason to panic if it prevents some security vulnerabilities. Like in this example, when we don't allow access some memory we shouldn't access. So this is, yeah, good example. Function often have contracts. Their behavior is only guaranteed if the inputs meet particular requirements. Panicking when the contract is violated makes sense because a contract violation always indicates a caller-side bug, and it's not kind of error you want to call in code have to explicitly handle. In fact, there is no reasonable way for calling code to recover. The calling programmers need to fix the code. Contracts for a function, especially when a violation will cause a panic, should be explained in the API documentation for the function. Yeah, a bit of abstract, it sounds like clear, but it would be nice to have some example on it. So if you doing with the function something unexpected which is documented, yeah, you probably will not get an error, just a panic if you violate the contract. However, having lots of error checks in all of your functions would be verbose and annoying. Fortunately, you can use Rust type system and thus the type checking done by the compiler to do many of the checks for you. If your function has particular types as a parameter, you can proceed with your code logic knowing that the compiler has already ensured you have a valid value. For example, if you have a type rather than an option, your program expects to have something rather than nothing. Okay. Your code then doesn't have to handle two cases for the sum and none variance. It will only have one case for definitely having a value. Code trying to pass nothing to your function won't even compile, so your function doesn't have to check for that case at runtime. Another example is using an unsigned integer type such as u32, which ensures that parameter is never negative. So yeah, each time, like on each step in your code, having this error handling could be very annoying and overwhelming. So it says some of them, or maybe most of them, we can have on the type level. So if our contract with the function, for example, on the type level, we will never need to recheck it's okay, because Rust compiler will do it for us. Or more simple example, yeah, we don't need to check if this is negative number, in case we already said it's unsigned 32, because it's always positive, or null, or zero, sorry. So yeah, okay, we have some example. Creating custom types for validation. Let's take the idea of using Rust type system to ensure we have a valid value on step further than, and look at creating custom type for validation. Recall the guessing game in chapter 2, in which our code asks the user to guess a number between 1 and 100. We never validated that the user guess was between those numbers before checking it against our secret number. We only validated that the guess was positive. In this case, the consequences were not very dire. Our output of too high or too low would still be correct, but it would be a useful enhancement to guide the user toward valid guesses and have different behavior when user guesses a number that's out of range versus when a user type, for example, letters instead. One way to do this would be to parse the guess as i32 instead of only u32 to allow potentially negative numbers, and then add a check for number being in a range like so. So what is going on here? Sorry, I need to quickly answer. I'll be back in a few minutes. Yeah, I'm back. Okay, so we have a code snippet here where we parse i32 from the user input. It's not in this snippet, but maybe we can quickly look if I still have this code in guessing game. So there is yeah, here's the input, and in the first place we use use32 here, but we can comment and do i32 instead. In case of error, we continue. So before negative number should fail, let's quickly test it. Cargo run -22. Input error. All right, and if we do -22 is too small, so you see now it's not show us the error, but the input out of range, so we can add following. Following, we can add following check. So -10. The secret number will be between 1 and 100. So yeah, you see it works fine. So the if expression checks whether our value is out of range, tell the user about the problem and call continue to start the next iteration of the loop and ask for another guess. After the if expression, you can proceed with the comparison between guess and secret number, knowing that guess is between 1 and 100. However, this is not an ideal solution. If it was absolutely critical that the program only operates on values between 1 and 100 and it had many functions with this requirement, having a check like this in every function would be tedious or might impact performance. Instead, we can make a new type and put that validation in a function to create instance of the type rather than repeating the validation everywhere. That way, it's safe for function to use the new type in their signature and confidently use the values they receive. Listing 9.13 shows one way to define guess type that will only create an instance of guess if the new function receives a value between 1 and 100. Alright, so instead to do the check every time, we can create a type which will do the check on the creation. Makes sense. Sounds like a good idea. let's quickly try to add it to our guessing game program. So what we have, we create new struct guess, which value is i32. We add implementation to struct guess with pub function new. Where we do this check or a panic. And we can get value from the function value. Let's quickly try to use it. So instead of this, we create throw value. Yeah. So we create new guess structure type. Yes, and here we need, we need to call value. And this should work. So if we do 22 is too small, the app is working, but if we do 0, for example, it panicked. You see, guess value must be between 1 and 100, so it panicked on the type level. And this is actually a good place to use backtrace. Yeah, sorry, it's typo here. So if we press 0, we can see there is error in guess structure implementation on 959, but also in the main RC 3921. So it's here on this line we have the panic. All right, this is understandable. So first we define a struct named guess that has a field name value that holds an i32. This is where the number will be stored. Then we implement an associated function named new on guess that creates instance of guess value. The new function is defined to have one parameter named value of type i32 and return a guess. The code in the body of the new function tests value to make sure it's between 1 and 100. If value doesn't pass the test, we make a panic call which will alert the programmer who is writing the calling code that they have a bug they need to fix because creating a guess with a value outside of this range would violate the contract with the guess new is relying on. The condition in which guess new might panic should be discussed in public facing API documentation. Will cover documentation conventions indicating the possibility of a panic in the API documentation that you create in chapter 14. That's cool. If value does pass the test, we create a new guess with its value field set to the value parameter and return the guess. Next, we implement a method named value that borrows self. Doesn't have any other parameter and returns an I32. This kind of method is something called a getter because its purpose is to get some data from it field and return it. This public method is necessary because the value field of guess struct is private. It's important that the value field be private, so code using guess struct is not allowed to set value directly. Code outside the model must use the guess new function to create an instance of guess, thereby ensuring there is no way for guess to have a value that hasn't been checked by condition in the guess new function. Yeah, this is kind of clear. This just explain the code snippet. Our value is a private. Is it private? Can we just do I don't know. So if we do so it's not really private. Thank you for the follow, Mr. Pix. Yeah, welcome to the stream. We are reading the Rust book here and play around with examples. So what I'm trying to understand now, it says like we're using getter for the private field, but I think it just should be private, but in this case it's not really private. Am I wrong? What? I can access it, so I maybe can set the value. If, for example, if I do it mod, and Yeah, maybe just let's get example from Compile.it and do +1 and run it again. So 22 input, and yeah, this is what I was thinking. So the value is like, in this example we're using getter, but it's not really private, this value field. So yeah, to make like it proper way, we should make it private somehow with namespaces or something like this. I think it just in terms of simplicity. So it's important that the value field be private, so code using, oh, so it's not says it's private, it's important to value be private. Okay, then we are fine. So there is the summary of the chapter. Rust error handler feature are designed to help you write more robust code. The panic macro signals that your program is state it can handle and let you tell the process to stop instead of trying to proceed with invalid or incorrect values. The result enum uses Rust type system to indicate that operation might fail in a way that your code could recover from. You can use result to tell code that calls your code that it needs to handle potential success or failure as well. Using panic and result in appropriate situation will make your code more reliable in the face of inevitable problems. Now that you have seen useful ways that the standard library uses generic with the option and result enum, we'll talk about how generics work and how you can use them in your code. So yeah, basically summary is we have two ways of handle some invalid situations, is the panic, which will close our app, or the result, where we can handle like two ways of our input, etc. So I think we will feel better this topic when start actually writing some our application, but yeah, for now it's the concept. There is way where you can prefer do one thing over another, and if we will need in future to back to this topic where it's good idea to have panic or something, we can back to this section of chapter 9. But yeah, okay, we have another new follower, DGenTV. Welcome to the stream, thank you for the follow. So yeah, maybe let's jump to the chapter 10. It looks very promising. Look, generic types, traits, and lifetimes. Super interesting topics. We kind of spoiled about it in previous chapters, but like not really understand what it is from it. And here we can start to get to know it better. So yeah, let me have a sip of my coffee. And let's start with the intro. of this chapter. Every programming language has tools for effectively handling the duplication of concepts. In Rust, one such tool is generics, abstract stand-ins for concrete types or other properties. We can express the behavior of generics or how they relate to other generic without knowing what will be in their place and when compiling and running the code. Yeah, generics we kind of work a lot already in the Rust while reading the book, but still it wasn't covered. But yeah, for me it's familiar topic. It's used, for example, in TypeScript I'm using every day, so not super new concept. Should be not hard to understand it. So functions can take parameters of some generic types instead of concrete type like ICT2 or string. In the way, function takes parameters with unknown values to run the same code on multiple concrete values. In fact, we've already used generics in chapter 6 with option, and option take generics t, chapter 8 with vector, with hash map and results. In this chapter you explore how to define your own types, function and methods with generics. Okay, this is cool. First, we will review how to extract a function to reduce code duplication. Well, we'll then use the same technique to make generic function from two functions that differ only in the type of their parameters. We'll also explain how to use generic type in struct and a num definition. Okay. Then you learn how to use traits to define behavior in the generic way. Yeah, these are traits I'm really curious about because it looks like some fundamental part of the Rust. You can combine traits with generic type to constrain generic type to accept only those types that have a particular behavior as opposed to just one type. Finally, we discuss lifetimes, a variety of generic that give the compiler information about how references relate to each other. Lifetimes allow us to give the compiler enough information about borrowed values so that it can ensure reference will be valid in more situations than it could without our help. So yeah, another really important concept. So let's start with removing duplication by extracting a function. So generics allow us to replace specific type with a placeholder that represent multiple types to remove the code duplication. Before diving into generic syntax, then let's first look at how to remove duplication in a way that doesn't involve generic type by extracting a function that replaces specific values with placeholder that represent multiple values. Then we'll apply the same techniques to extract a generic function. By looking at how to recognize duplication code you can extract into a function, you'll start to recognize duplicated code that can use generics. We begin with short program enlisting 10, one that find the largest number in the list. So as usually, let's create new project, cargo new, let's name it generics 10, open with NeoVim. So let number list vec, and let's use Copilot to fill it. Let mat largest, so reference to the first array element, not array vector, sorry. And for number in reference number list, largest number. Okay. Yeah, and print the result. And let's quickly run it. So we store the list integers in the variable number list and place reference to the first number in the first variable named largest. We then iterate through all numbers in the list, and if the current number is greater than number stored in the largest, replace the reference is that variable in that variable. However, if the current number is less than or equal to the largest number seen so far, the variable doesn't change and code moves to the next number in the list. After considering all the numbers in the list, largest should refer to the largest number, which in this case is 100. Yeah, exactly. Just quick explaining what this snippet of code doing. Quite obvious. We've now been tasked with finding the largest number in two different lists of numbers. To do so, we can choose to duplicate the code in listing 10.1 and use the same logic at two different places in the program as shown in listing 10.2. So you see, we did it once, we did it twice, so it's definitely just copy pasting the code, but just use different vector. So I assume we should, if it's like regular rule for any programming situation, I don't know, you're doing daily, like if you see some duplication, it's sign you should do refactoring. So if it's some function, place this code in the function. If it's some, I don't know, if you're familiar with, for example, React.js, is it like two components with the same code, create some common component, etc. With, yeah, some configurable component that can replace this duplication. Also, this code works. Duplicated code is tedious and error prone. We also have to remember to update the code in multiple places when we want to change it. To eliminate this duplication, we'll create an abstraction by defining a function that operates on any list of integer based in a parameter. This solution makes our code cleaner and lets us express the concept of finding the largest number in a list abstractly. In listing 10.3, we extract the code that finds the largest number into a function named largest. Then we call the function and find the largest number in the to list from 10 to. We could also use the function on any other list of ICT2 values we might have in the future. So yeah, let's try to do it ourselves. So we need function largest, which will take list what is the type? Vector ICT2. Is it something like this? And what we will return? ICT2, I guess, as well. Then we can put code here and let's change the name because the function is largest. Oh, we still can use it, it's not a problem. No, it's look like it's not good idea. That's something wrong. Oh, yeah. Should be angle brackets. Yeah, at this point, let's compare what is. Okay, you see, this is the different from our implementation. So list. It's already a reference. I guess it's something like this. No, this one is still a reference. And you see it's working. And we can create another vector with different values and invoke the function. and the code is much smaller if we write this code twice, but we just use the function twice. But I guess the next step will be make it work not only for i32 but for different types, and this is the place where generics should come into the game. So the largest function has a parent called list, which represent any concrete slice of i32 values we might pass into the function. As a result, when we call the function, the code runs on the specific values that we pass in. Summary: here are the steps we took to change the code from listing 10.2 to listing 10.3. Identify duplicated code, extract the duplicated code in the body of the function, and specify the inputs and return values of the code in the function signature. Update the two instances of duplicated code to call the function instead. Okay, the next we use the same steps with generic to reduce code duplication in the same way that the function body can operate on the abstract list instead of specific values. Generic allow code to operate on abstract types. For example, say we had two functions that find the largest list slice i32 values and one that find the largest item in the slice of char values. How would we eliminate the duplication? Let's find out. So this is first section of chapter 10. Yeah, it looks quite big. I don't really have the time right now to finish it, so let's jump to the Rust-Link exercises. And we will continue with the book on the next stream. So let me a bit change layout. Where to place? Maybe somewhere here. Okay, so and the error primitive type 6. Let me rerun Rust-Link Watch. Okay, now we have error for vex, so we will practice vector. New task is create a vector which holds the exact same elements as an array. To declare your vector here with the macro for vectors. So I just need to do that same array like this, or what? So maybe let's take a look at test. So we use our function here, which return two vectors. And what is the error? Vectors, vector 1, line 13. Let me restart LSP. Let me restart NVIDIA, I don't know. Information is not available. Why it's not showing me? Oh, yeah, now I get it. I just need to use vector macro. No. Oh, this is should be a plain array, and this is should be a vector. Let's ask Copilot. A plain array. Okay. Declare your vector here with the macro and vectors. So basically same what we have here, right? Oh, just one wasn't run, it's successful now. So for some reason it stopped run automatically. Let me try to rerun it. So now we need vector to file. So make me pass the test. Okay. A vector of even number in given is a given. Your task is to complete the loops so that each number in the vector is multiplied by 2. Make me pass the test. Execute. Okay. So for I in So can I just do something like this? Cannot use on type. Okay, like this. And the reference and the reference here. Okay, this was vector. It was mutable vector. Here we just returning the num. Yeah, you see, we just do map and I guess map function. I don't know why my LSP is not working here. Maybe because I updated NeoVim yesterday. But anyways, the map, I guess something same as in JavaScript. We just create new array vector or something, iterating through each value and returning some new values. So let's mark it as done and see the next exercise. So now move semantics. Okay, this is related to the ownership, I guess. So execute or use the hint. What's okay? So what the error say to us? Cannot borrow as mutable on the line 13. So the vector 1 is not immutable, so we cannot push anything here, I guess. We just do it map. Will it change the situation? Yeah, exactly. Let's go next. Make me compile without changing line 13 or moving line 10. So this is line 13. We will not change it. Or moving line 10. So we have mutable vector. What is the error? Value borrowed here after move. So we have mutable vector. And what we can do about it? So there is a note. Consider changing this parameter type and function fill vector to borrow instead of owning. Okay, so maybe we just need pass the reference instead of no. Oh, we have fill vector, so can we do it like this? So what is going on here? Maybe we should clone it. Yeah, this was actually first interesting exercise because I don't really understand what I should do here. So we don't move ownership, we just borrow with the reference, then we do clone. And then we are fine. Okay, let's move to the next one. Make me compile without adding new line, just changing existing lines. No lines with multiple semicolons necessary. Okay. So the first error on the line 21. Cannot borrow vector is mutable as it is not declared as mutable. So we need mutable vector here, I guess. Maybe like this. So maybe I can do mutable vector and return mutable vector. No. The syntax is incorrect. So maybe need to use references here. Yeah, let's start from scratch. Make me compile without adding line, just change existing lines. So maybe or use hint watch command. How to use hint? I never did it before. So welcome to watch mode. You can type help to get an overview of the command you can use here. The difference between this one and the previous one is that the first line of function fillVec that had let mutable vector vec is not longer there. You can, instead of adding line back, add mutable in one place that will change an existing binding to be immutable binding instead of immutable. So yeah, this was the direction, but it says in one place. So can I do like this? Cannot borrow as immutable. line. Says in one place. Really, just in one place. Okay. So here we move ownership and make it mutable. Refactor this code so that instead of passing vector 0 into the fill vector function, the vector gets created in the function itself and passed back to the main. So I guess okay. That was the easy one. Let's continue. So move semantics 5. Make me compile only by reordering the lines in main, but without adding, changing, or removing any of them. Execute. Okay, so let's see without there and try to understand what the problem here. Create mutable x, then we borrow mutable x here, then borrow mutable x here. So we cannot do multiple borrowing, so I think just need to do something like this. Yeah. So execute. No, you can change anything except adding or removing references. So we need to add reference. We have a string here, get char. Okay, what is the error here? Let's see. Okay, move occurrence because data has type string, which does not implement the copy trait. All right. Get char. While I moved here. So yeah, first of all, then let's don't move it. And what else? Expected string font reference. Yeah, and also okay, there is some hints. Should not take ownership. We don't. Should take ownership. If we do it like this. All right. So we finished the move semantics. What is next? Exercise structs. Yeah, structs interesting, but maybe we jump to it on the next stream. And I think, yeah, that's it for today. Thank you for watching. Well, glad to see you next time.